Welcome to my channel Anishbagchi.learning. Today I will discuss about mathematical reasoning. This is very important chapter for joint entrance and also board. To start the mathematical reason, first we have to discuss about mathematical statement. What is statement? Statement or proposition. A statement is a sentence that can be true or false, but not both simultaneously. Suppose Ram play football. Ram may play football or may not be. If Ram play football, then it is true. And if Ram does not play football, then it is false. But it cannot be simultaneously true and false. So it is a statement. Now, play football. It cannot be true or false. It is an instruction. So it cannot be true or false. So it cannot be a statement. Ram is a good boy. Ram is a good boy. Good boy is a very relative characteristics. It may be good to someone and he may be bad to someone, or his character may be questionable to someone. So it cannot be a statement. Next, give me a glass of water. This is an order. So any order cannot be a statement because it has no truth value. That is, it cannot be true or false. Sentence end with interrogation, exclamation signs are not a statement. This is a very important part. Now, next, atomic statement. When a statement which expresses a single idea is called an atomic statement. Ram play football. It is an atomic statement. Next, truth value. A statement, either it is true or false. This is called its truth value. A statement may be true or false if T for true and F for false. Assignment of a statement on the basis of true or false is called its truth value. Next, compound statement. When two or more statements joined by connectives, then that statement is called compound statement. When a statement contains two or more atomic statements, the statement is called compound statement. Now, suppose A greater than B and B greater than C. There are two different, this is one A greater than B, and these are the two atomic statements joined by and. This is called compound statement. Next, Rohim is a student or Rohim is a player. Rohim is a student is an atomic statement. Rohim is a player is an atomic statement. And these two statements are joined by or. So it is a compound statement. Next, if you love mathematics, then mathematics will love you. This is also a compound statement. You are eligible for science if and only if you love mathematics. Now, this or, if, then, and if and only if, these are called connectives. Now we will discuss about connectives. Logical connectives. The word which are used to connect two statements to form compound statement is called logical connectives. Or, and, not, if and then, and if and only if are the connectives. Unary connectives. Not is called the unary connectives. Next, binary connectives. All the other connectives, that is or, and, if, then, if and only if, are called binary connectives, because in case of unary connectives, it only assigns one statement. That is, it will not connect two or more statement. But or, and, if, then, if and only if connects two or more statements. So they are binary connectives. Next, symbols of connectives. Symbol of not, either this or this. This or this. These are the symbol of not. Or. This V is the symbol of or. And. Inverted V is symbol of and. If and there. This is also called implies. If and then or implies. Implies single arrow or double arrow. This is implies. Okay. Next, if and only if. These are the symbol of if and only if. Now, propositional variables. Propositional variables P, Q, R and S and T, C are denoted atomic statements. These letters are called propositional variables. Suppose Ram play football. We can take P is equal to Ram play football. So P represent this statement. Next, conjunction. Conjunction, and is called conjunction. Symbol inverted V or and simply. When two atomic statements are joined by and or inverted V, the process is called conjunction of two statements. Now the truth value of the conjunction statement. Suppose P 8 is divisible by 2. Q 7 greater than 3. If we join these two by and, this is P and Q, 8 is divisible by 2 and 7 greater than 3. So this is the conjunction of the statements. Now, truth table of the conjunction. It can be compared with series connection of electricity. Suppose this is a switch P, this is a switch Q, and these are connected to a battery and a light. So to complete the circuit, we have to close both the switches. So when both are open means false and close of switch means true. So when both are true, then light will glow. If any one is off in off position, then light will not glow. That means we can, so true and true is equal to true. True and false. So one switch remain open, so light will not glow. So this is false. False and true is false. False and false is false. So this is a truth table of conjunction, that is and. Next, disjunction. Or is a disjunction connectives and it is symbolized by V. When two atomic statements are joined by or V, then process is called disjunction of the two statements. This is inclusive or. This is very important. There are two or, one exclusive or, another inclusive or. This is inclusive or. Example, P 8 is divisible by 2, Q 7 greater than 3, and disjunction of 2 is 8 is divisible by 2 or this is a 7 greater than 3. Now it can be compared with parallel connection. If we connect to parallel switch and then connect to the battery, and this is the light. So to glow the light, any one of the switch is closed, then light will glow. If both the switch close, then light will glow. But if both the switch in off position, then light will not glow. So from this we can say that its truth value or truth table, true or true is equal to true. That is on and on, both are on, it become true. True and false, one of the switch is on and another off, so it is true. False and true, but false and false is false. This is a truth table of disjunction. Next, exclusive OR. It is also called XOR. Symbol of exclusive OR is this. This is a symbol of exclusive OR. Now, the difference of exclusive OR is if both are true, then it is false. And if both are false, it is false. Now, note that the equivalent statement P or Q, that is exclusive OR P XOR Q, equivalent to P or Q and not P and Q. This will be helpful for simplify the relation, so you should remind it. Next, negation. Negation, this is very simple. If P is a statement, not P or this is called the negation statement. Rohim is older than Ishan. Rohim is not older than Ishan. This is very simple. Just you have to introduce not in the sentence. Then we will get the negation of the previous statement. And truth table, if Rohim is older than Ishan, if it is true, then it should be false, and if it is false, then this will be true. So negation of true is false and negation of false of true. Next, conditional or implication. Conditional statement P arrow Q, and it is if and then is the connectives, or we can say that P implies Q. When two statements are interrelated such that first statement is hypothesis and the second statement is conclusion or consequent. First statement is called antecedent and second statement is consequent. The statement is called conditional statement. Suppose 3 points are non-collinear. This is an atomic statement. And Q be one circle can be drawn through 3 points. Now, if we convert it into conditional statement, then P implies Q is equal to, if 3 points are non-collinear, then one circle can be drawn through 3 points. Here, if and then is the connective of the statements. Now, truth table. If antecedent is true and conclusion is true, then the statement is true. If antecedent is true but conclusion is false, then it will be false. Next, antecedent is false but conclusion is true, then it will be true. And if both are false, then it will be true. And P implies Q, its equivalent expression is not P or Q. This is very important. Next, converse of a statement. If we antecedent and consequent reverse, then that statement become converse of the previous statement. Suppose P 3 points are non-collinear. With respect to the previous example, we can say that P 3 points are non-collinear. Q, one circle can be drawn through 3 points. P to Q, if 3 points are non-collinear, then one circle can be drawn through 3 points, and its converse statement Q to P. Just reverse the statement. If one circle can be drawn through 3 points, then 3 points are non-collinear. Now, converse statement of the conditional statement are not equivalent. That means their truth value are not equal. P implies Q not equivalent to Q implies P. This is very important. If we draw a truth table, then we can say that. Suppose P, Q, P is true, true, false, false, and true, false, true, false. Then P to Q, this is true, this is false, this is true, and this is true. But Q to P, this is true, this is true, this is false, this is true. So, we can say that truth values are not equivalent. Therefore, P implies Q not equivalent to Q implies P. Clear? Next, inverse. Inverse of a statement. If negation of both antecedent and consequent are relating the conditional statement, the statement is called inverse of the conditional statement. That means we have to introduce not in the conditional statement, then we will get inverse of the conditional statement. 3 points are non-collinear, then its negation of this, negation of P will be 3 points are collinear. Next, one circle can be drawn through 3 points. So we can say that negation of this will be easy. Negation of Q is equal to one circle cannot be drawn to 3 points. Now, P and Q, if 3 points are non-collinear, then one circle can be drawn through 3 points. And its inverse statement, if 3 points are collinear, then one circle cannot be drawn through 3 points. Clear? And it is also not equivalent to P implies Q. If we form the truth table, then we will find that it will not equivalent to P implies Q. Next, contrapositive. Contrapositive, when negation inverses, that is converse of inverse, that is contrapositive. Converse of inverse of a conditional statement is called contrapositive of the conditional statement. If P and Q, P implies Q is conditional statement, then not Q implies not P is contrapositive statement. And contrapositive statement is equivalent to the statement itself, conditional statement. 3 points are non-collinear. One circle can be drawn through 3 points. So P implies Q. If 3 points are non-collinear, then one circle can be drawn through 3 points. Not P, not Q. Not P implies not Q. If one circle cannot be drawn through 3 points, 3 points are collinear. Now, P implies Q equivalent to not Q implies not P. That is, conditional statement is equivalent to contrapositive of the conditional statement. If we prepare the truth table, then we can find it. That is, suppose P and Q, true, true, false, false, true, false, true, false. Then not P, false, false, true, true. Not Q, false, true, false, true. P implies Q, true, 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 false, 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 true, true, false, false, true. Now, false, false, negative Q, not Q, true, not P. That means F implies F is true, true implies F is false, F implies true is true, and true implies true is true. So, if you observe it, all the statements are truth value are same. So, we can say that this equivalent to this. Biconditional statement. This is a double arrow. P and the connective is if and only if. A wave can propagate only through surface of a medium, and Q, it is a transverse wave. Then biconditional statement of these two, a wave can propagate only through surface of a medium if and only if it is transverse wave. Now, truth table of this, true to true is equivalent to true, true false false, false true false, and false false true. The difference between this conditional and biconditional, true false is false and false true is true. So this is different for biconditional, differs from biconditional. So if we convert this statement in case of biconditional, then it becomes equivalent to the previous, that is biconditional statement. The biconditional statement and its converts are equivalent. Next, tautology. Tautology can be compared with the universal set in the case of set. Tautology, that is, it never depends the truth value of atomic statement. It is always true. A tautology is a compound statement that is always true regardless of the truth values of the individual statements. Tautology can be compared to universal set. It is symbolized by T. This is an example of tautology. P or not P equivalent to T. This is a P or not P is a tautology. Now, if statement from P and Q, P may be an atomic statement or it may be a compound statement, Q may be an atomic statement or compound statement, then P biconditional Q is a tautology always. If P and Q are logically equivalent, then this is a tautology. Examples. These are some examples of tautology. If we prepare the truth table, then we will find that suppose P, Q, true, true, false, false, true, false, true, false. Now P and Q. So this is true, false, 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 not P. So negation of P, false, false, true, true. Negation of Q, false, true, false, true. Now P and not Q. So P and not Q. P and not Q. And so true, false, false, true, 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 false, 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 true, false. Now not P, to or this, not P, P and not Q. That is, not P is here, true, false, 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 true, 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 false, true, true, false, true. Now this and this, P and Q or this final statement, true, false, false, true, 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 true. So all are true. That is why we can say that this is tautology. In this way, we can prove whether an expression is a tautology or not. Next, these are the examples of tautology. You may prove that. Now, contradiction. Contradiction just opposite to tautology. It is always false, regardless the truth value of the individual statement. Contradiction is a compound statement from form that is always false regardless of the truth values of the individual statements. Contradiction can be compared to the empty set. It is symbolized by C. P and not P is a contradiction. Now, different laws are very helpful to get the result. First, commutative. We can establish that by truth table. P and Q is equal to Q and P. So if we interchange the atomic statement, their position, then it remain same truth value. So they are equivalent. That is called commutative law, commutative laws. And or also P or Q equivalent to Q or P. Next, associative. If P, Q or C proposition, P and Q whole and are equivalent to P, that is, if we take this as one statement, P and Q, and it will combine with R, that will be equivalent to P and Q and R. And also or, in case of or, it is equivalent. This is called associative law. Next, identity. Any proposition when P and tautology is equal to P and P or contradiction is equal to P. These are identity law. Next, negation law. P or not P is equal to tautology. That means whole thing. Suppose Ram is a player or Ram is not a player. So if it is true, then it is false, and true plus false is equal to true. And if it is false and this will be true, so true or false is equal to true. It remains always true. It may be tautology. Next, double negative. Negation of negation P is equal to P. This is simple. Idempotent law. P and P is equal to P. P or P is equal to P. This is idempotent law. Universal bound law. P or T is equal to T. And P and C is equal to C. We can easily prove by table. This is very important, De Morgan's law. Negation of P and Q is equal to negation of P or negation of Q. That is and converted into or. And also negation of P or Q equivalent to negation of P and negation of Q. That is, if we put a negation before and or, then and will be converted into or and or will be converted into and. Absorption law. This is also important. P or P and Q is equal to P. So Q will be absorbed. So it is called absorption law, law of absorption. P and P or Q. If it is or, then it will be and. If it is and, it will be or. And combining these two, then Q will be eliminated or absorbed. Negation of T and C. Negation of C is equal to T and negation of T is equal to C.